Hello, everybody. How are you today? This is Mr. Jubert, and today I will be giving a lecture about balance and unbalanced forces. This is also an introduction on the topic about forces. Now, this topic is one of the topic in the physical science class for SME and MEP students of Mari Vitaya Kabenbury School. So I hope you will enjoy this video and please watch and listen until the end. So let us start. What is force? Force is a push or a pull that one object exerts on another. So it is a push or a pull. Now, how do you describe a push and how do you describe a pull? Okay, so the direction of the push is away from the object that exert the force. And how about the pull? The direction of the pull is towards the object that is exerting the force. Okay? Now, if you are going to push an object, the object will move away from you. And if you are going to pull an object, the object will move towards you. Now, force is responsible why objects around us moves. So if you are going to apply force to an object, the object will move. Force also has size and direction. We can measure the amount of force exerted by an object to another object, and we have also a particular direction where the force is moving. Just like, for example, we have an upward force, we have also downward force and others. So that is force. It is a push and a pull. What makes an object change speed or direction? Speed means the object can move faster or slows down. And what makes an object change direction or move to another point? That is because of the forces around us. I say forces because there are a lot of force that affects our life here on Earth. Now, these forces in our planets are responsible in making all the things around us to be in order. It makes our life balanced. So, I will be talking about the kind of forces in the next topic. What is a Newton? Forces are measured in newtons. So in other words, Newton is the unit of forces. Why? Because forces can be measured. So if they can be measured, they are given in the unit of Newton. 1 Newton is equal to the amount of force needed to accelerate 1 kilogram mass 1 meters per second squared. In other words, a kilogram mass exerts about 9.8 newtons of force. To put that in perspective, about half of one of Isaac Newton's apples would exert 1 Newton of force. I told you a while back that there are a lot of forces that acts on the object around us. So, when multiple forces act on the same object at the same time, the forces are combined to form a net force. So the net force is the combination of all forces acting on an object. So forces are represented by arrows. So greater force are represented by longer arrows. Arrow thickness can also be used to show forces. So the size of the arrows can represent the amount or the magnitude of forces acting on an object. Examples of a net force. Number one. So we have here number one example, 5 newtons, and another one, 5 newtons. So 5 newtons plus 5 newtons is equivalent to 10. So that is the net force. Now, we simply add them together because they are moving at the same direction. Okay? Number two example. We have also 5 newtons plus negative 5 newtons. Why is that this one is negative? Because this force is moving opposite of the other force, which is a forward force or a positive force. So the answer here is 0. Number 3, we have 5 plus 10 newtons. It's equivalent to 15 newtons. Okay, we simply add this one because they are moving at the same direction. Number 4 example, we have 5 plus negative 10 is equivalent to negative 15. Again, this is negative because it is a negative force. It is moving opposite of the positive force. Number 5. 5 plus 15 will give us an answer of 10 newtons because 15 again is a negative force. Number 6. Okay, we have here an upward force, 10 newtons, plus a downward force that is negative 5. So if we are going to compute for the net force, our answer will be 5 newtons. There are many different forces which act on objects. If forces are balanced, the object doesn't move. What is the meaning of the word balance force? If we see balance force, the negative and the positive forces are equal. Okay? They are equal. So what will happen? The object doesn't move. There will be no movement. Okay? How about if the force is unbalanced? If the force is unbalanced, the object will move on the direction of the bigger force. So if forces are balanced, the object will do one of the following things. One, begin to move, stop moving, change direction, speed up, and slow down. So these are the effects of unbalanced force. It will make an object to begin moving, stop moving, change direction, speed up, or slow down. Balance force. Okay, balance force do not change motion or there will be no movement. Cancel each other. Why? Because they are equal. Combine to produce a net force of 0. If the net force is 0, then the force is balanced. Unbalanced force. Unbalanced force do not have the same strength or size. This will cause an object to accelerate or it will make the object to start moving to speed up or to slow down. Now, we have here an example of a balanced and unbalanced force. Now, I told you that forces are represented using arrow. Okay? So, in a tug of war, each side exerts a force on the ground. If the opposing forces on the ground are equal, they are balanced and the people do not move. So there will be no movement here because the opposite forces are equal. Okay, nobody will win. How about this one? If we look at the arrow here, the other one is longer and the other one is shorter. Meaning to say, the size of the two forces are not equal. So if the forces on the ground is greater than the other, the forces are unbalanced. And the people move in the direction of the greater force. We have here a force diagrams. In the first diagram, we have here a truck acted by two forces. We have here the forward force that is 100 newtons and the opposite force is 100 newton. So, what do you think will happen to the truck if these two forces will continuously act on the truck? The truck will stay still. Okay, it will not move. How about diagram number 2? So we have here a bigger force that is 100 newtons and a smaller force that is 60 newtons. So if we are going to look at this one, looking at the size of the forces, it is unbalanced. So what will happen? The truck will move towards the direction of the bigger force. It will move forward. Balanced forces. When two forces acting on an object are equal in size but are opposite in direction, we say the forces are balanced. Okay? Balanced force do not cause a change in motion. Just like this one. This illustration shows a balanced force. The elephant pulling each other will not move to any direction because they are exerting the same amount of force. The ship is floating on the water. The forces are balanced. Which forces are acting on the ship? So we have here the downward force, which is the gravity, and we have the upward force, which is the water's upthrust. Now, the gravity and upthrust are equal, so the ship stays afloat. But if the upthrust force is smaller than the downward force, what will happen to the ship? The ship will sink. The vase is resting on the table. It is not moving, therefore the forces must be balanced. Which forces are acting on the vase? So we have here the downward force, which is the gravity, and the table's upthrust force. Now, have a look around you and name some of the balance forces and action on different objects. Let's have the unbalanced forces. When two forces are acting on an object and are not equal in size, we say the forces are unbalanced. Unbalanced forces cause a change in motion by changing the object's speed or direction. Example, we have here an airplane moving up. So from the runway, it moves from the runway and after that it moves up because the lift force of the airplane is higher than the downward forces that pulling the airplane downward. The unbalanced force changes the direction of a moving object. Now, just like the airplane, it undergoes change and direction because of the unbalanced force by the wind and the atmosphere. In this illustration, when the truck and the car collides, the truck motion is changed, but the ladder keeps going. The collision between the truck and the car causes unbalanced forces, which made the truck to stop moving, while the ladder continuously moves because the unbalanced forces is only between the truck and the car. This illustration can be explained by the first law of motion, wherein an object in motion will stay in motion and an object at rest will stay at rest unless acted upon by unbalanced force. Another example of unbalanced forces. The man and the parachute are slowly falling to the ground. Which forces are acting on the parachute? Which force is bigger? How can you tell? So we have here two forces acting on the parachute. We have the gravity that is also falling the man to the ground and the air resistance pushing it upward. Now, which force is bigger? The gravity is bigger. We can tell this because the direction of movement of the man and the parachute is the same as the direction of the force. And at the same time, if we are going to look at the size of the arrows used in the illustration, the arrow for gravity is bigger than the air resistance. Okay, the same forces are acting on the elephant, but without the parachute, there is much less air resistance. Okay, look at this one. The gravity is much bigger force because there is a bigger difference between the force of pulling downwards and the force pushing upward. The elephant falls much more quickly than a man with a parachute. Okay, we have here also an unbalanced force caused by the force of magnets. The paper clips jumping up to the magnet. Which forces are acting on the magnet? What is the greater force? So we have here the magnetic force is pulling the paper clips upwards. And we have also the gravity pulling the paper clip to the ground. So the magnetic force is greater than the force of gravity. Therefore, the paper clips moves in the direction of the biggest force. In this illustration, the arrows used to represent the forces of the two arm wrestlers are not equal. Based on their length, the blue wrestler exerts more force and the red wrestler exerts lesser force. So, the question is, which arm wrestler will likely win? Which direction will both arms move? So, the blue wrestler will win, and the direction which both arms move is in the direction of the bigger force used by the blue wrestler. Okay, we have here another illustration. So we have here two forces represented by two arrows, a longer arrow and a shorter arrow. So we have here 4 newtons is the short arrow and the long arrow is 10 newton. Question, which direction will the rope move? So the rope will move in the direction of the blue arrow. Why? Because the blue arrow exert or compose of bigger force. Newton's second law of motion, or in other words, this is also called the law of inertia. The law of inertia explains why forces tends to be balanced or unbalanced. The law of inertia is the tendency of an object to stay at rest or in motion unless acted by an unbalanced force. So a moving object will keep on moving and moving unless an unbalanced force will try to slow down or stop the moving object. An object at rest will stay at rest. It will not move if there is no unbalanced force that will try to make the object to start moving. That is the law of inertia. So objects with greater mass have greater inertia. Inertia keeps astronauts in space in motion. Why? Because there is no external forces pushing or pulling upon their body, so they just keep on moving or in motion. Seat belts protect against inertia. An object in motion stays in motion due to inertia. So, if you are wearing a seat belt, the seat belt would act as the unbalanced force. It would stop you from being in motion when the car collides with another object. So that is why every time we ride a car, we need to wear our seatbelt. In the next slides, I want you to tell me if the illustrations shows a balanced or unbalanced force. So, are you ready? Is this picture shows balanced or unbalanced force? What is your answer? Okay, look at this one. There are three people in each sides. So, the answer is balance force. Next, two people playing arm wrestling. So we have here a short arrow and a longer arrow. So if we are going to look at this one, the length of the arrow and the magnitude of the forces, this is unbalanced force, right? Okay, next, another one. We have here two person pulling the rope. So, we have here two arrows again. We have a red arrow and a blue arrow. The red arrow is shorter than the blue arrow. So that means this is balance or unbalanced. This is an unbalanced force. Okay. Next one, is this balanced or unbalanced? So we have here 500 newtons versus 450 newtons. So if we are going to look at the magnitude of the force, we have 500 newtons and 450 newtons. So, is this balanced or unbalanced? Okay, this is unbalanced force. Now, where is the direction of the force? The direction of the force will be the direction of the bigger force, which is 500 newtons. We have here another example or another illustration. And is this balanced or unbalanced force? We are going to look at this one. This is an example of unbalanced force. Okay. Is this balanced or unbalanced? Okay. I know you know the answer already, right? Based on the size of the two sumo wrestler, this is unbalanced. Okay, this is unbalanced. Okay. Now, before we end up, I want you to look at this picture. Okay? Now, analyze this one, and after that, you copy and answer these questions. Okay, so I have two questions for you to answer. The first question is, each team is exerting a force. What happens if the pulling force produced by each team is equal? So we have here equal force exerted by the two teams. And number two, we have what would happen if the team on the left were able to produce a bigger pulling force than the team on the right? So I want you to answer this one based on what we have discussed today. Okay? So I want you to write your answer in a piece of paper. Voila! This is the end of our topic for today. I hope you understand something, and I hope you learned something in my lecture. So, Thank you very much for listening and watching. See you next time. Bye bye.